notice the green colored mold on your bread spoiling it in few days? Spoilage increases all of a sudden within a few hours. Yes, it is a microorganism called bread mold. And how this microorganism relates to our topic? Due to binary fission process, the growth increases rapidly with a short duration. And this growth is called exponential growth rate. Now, let's see in detail about exponential functions. Let us consider a polynomial function x raised to n, where n is equal to 1, 2, 3. And the equation may be substituting the values, we get y equal to x, y equal to x square, y is equal to x cube, y is equal to x raised to 4. Now, if we try to draw a graph for x is equal to y for different values, we get a straight line. So, for x is equal to 1, y equal to 1. When x is equal to 2, y is equal to 2. Now, if we try to draw for y is equal to x square, now with reference to the graph y is equal to x square, we can notice that the curves get steeper as the power of x increases. For fixed increment in the value x greater than 1, y increases. Now again, we can draw a graph for y is equal to x cube as it is shown here. It is observed that the growth of the polynomial function is dependent on the degree of the polynomial function. As you can see, when y equal to x, y equal to x square, y is equal to x cube. The higher the degree, the higher the growth. Now, I'll ask you a question. Is there any function that grows faster in the polynomial function? Let's focus on that now. These are nothing but exponential functions. An exponential function with a base b greater than 1 is a function defined by y is equal to f of x is equal to b raised to x. For example, f of x is equal to 10 raised to x. F of x is equal to e raised to 2x. These are all the form b raised to x. Where, what is e? E is equal to 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial and so on. The exponential function with base 10 is called the common exponential function. The exponential function with base e is called the natural exponential function. Now, let us compare polynomial and exponential function. Let's take x is equal to 10 raised to 3. Now, substitute in both polynomial function and exponential function. We get y is equal to 10 raised to 300 in the case of polynomial function, and we get y is equal to 10 raised to 1000 in the case of exponential function. Why? Because here in exponential function y is equal to 10 raised to x, right? Now it is clear that the curve is steeper for the exponential function, and which means the function increases more than the polynomial function. Now let's study some features of the exponential function. The features of the exponential function is listed below. First one, the value of x is called domain and it is applicable for all real numbers. Second, the value of y is called range, and for any value of x, the value of range value would be positive real numbers. And the third one, the point 0,1 is always on the graph of the exponential function. That is for x is equal to 0, the value of y is equal to 1. And this is applicable to any exponential function. And we can see clearly in this graph. Have a look, it passes through 0, 1, right? Exponential functions are ever increasing. From the graph, we clearly understand that x increases, y also increases. As we move from left to right, the graph rises above. For very large negative values of x, the exponential function is very close to 0. So far we have learned about what are exponential functions. Now it's time to look on logarithmic functions. Let b greater than 1 be a real number such that b raised to x is equal to a. Then we say logarithm of a to the base b is equal to x. A logarithmic function is a function from positive real numbers to all real numbers. Then x tends to log x to the base b is equal to y if and only if b raised to y is equal to x. If base b equal to 10, it is called common logarithm. And if base b is equal to e, it is called natural logarithms. And log x denotes the logarithm function to the base e. Now, let's see some features of logarithmic function for b greater than 1. The features of logarithmic function, the first one is the value of x is called domain. The domain of log function is a positive real numbers. There is no meaningful definition for non-positive numbers. The value of y is called range. The range of log function is again the set of all real numbers. The point 1, 0 always lies on the graph. If the value of x is 1, the value of y is log 1, which is nothing but 0 for any base b greater than 1. And as the value of x increases, the value of y also increases. As we move from left to right, the graph rises above. Right? Now, next we compare natural exponential function, that is y equal to e raised to s, and the natural log function y equal to ln x. We observe that the two curves are the mirror images of each other reflected in the line y equal to x. Next, we can see the properties of log function. There is a standard change of base rule to obtain log p to the base a in terms of log p to the base b. So, let log p to the base a is equal to alpha if a raised to alpha is equal to p. Now, log p to the base b is equal to beta if b raised to beta is equal to p. Now, log a to the base b is taken as gamma if b raised to gamma is equal to a. Now, taking the first one, instead of a, give the substitution as b raised to gamma. Now, taking the first one, instead of this a, give substitution as b raised to gamma. And we get b raised to gamma into alpha is equal to p. Now, b raised to beta is equal to p, which is equal to, what is p? B raised to gamma into alpha. And on comparing, we can see that the powers beta is equal to gamma into alpha, or alpha is equal to beta by gamma. Now we have to substitute for alpha, beta and gamma in this equation, and we get log p to the base a is equal to log p to the base b by log a to the base b. And this is a very important equation, and this is how the change of base rule is done. And now the next property of log function is its effect on products. That is, log pq to the base b is equal to alpha if b raised to alpha is equal to pq. Now, log p to the base b is equal to beta if b raised to beta is equal to p. Now, log q to the base p is equal to gamma if b raised to gamma is equal to q. Now, what is b raised to alpha? B raised to alpha is equal to pq, which is equal to, what is this p and q? Substitute here. So, b raised to beta into b raised to gamma, and this can be written as b raised to beta plus gamma. Now, the bases are equal. Comparing the powers, we get alpha is equal to beta plus gamma. Now, substitute the values again. Log pq to the base p is equal to, what is beta? Log p to the base b. And what is gamma? Log q to the base b. Similarly, we get log p by q to the base b is equal to log p to the base b minus log q to the base b. If it is product here, the plus sign in between. And if it is division, the minus sign in between. Alright? Now, in this equation, what happens when p is equal to q? So, log pq is equal to log p to the base b plus log q to the base b. Now, when p equal to q, log pq to the base b, this is our equation. That is log p to the base b plus log q to the base b. Now, when p and q are equal, we get it as log p square to base b is equal to log p to the base b plus log p to the base b. And this RHS will become 2 log p to the base b. Again, this can be written as log p raised to n to the base b is equal to n into log p to the base b. And this is a generalized form. It is also provided that the natural exponential function in differential calculus does not change during the process of differentiation. Next, we will discuss how to do the differentiation of logarithmic functions, which is otherwise called logarithmic differentiation. Logarithmic differentiation can be used for a special class of functions which are expressed in the form y is equal to f of x is equal to u of x raised to v of x. Now, how to perform this logarithmic differentiation? Any idea? The first step, we have to apply the log on both sides. So, on applying what we get, log y is equal to the power, it will come down. So, v of x into log u of x. Now, next step, we have to differentiate using the chain rule. The chain rule is, what is log y derivative? Which is 1 by y into dy by dx. And here, this of the form u of x into v of x, the product rule. That is, v of x into derivative of log u of x. That is 1 by u of x into u dash of x plus v dash of x into the second function, that is log u of x. Again, we can write dy by dx taking y to the other side, and this is the expression for dy by dx. And here are the general steps to perform the logarithmic differentiation. First one, take a natural logarithm on both sides. Second, apply the property for the log of a product. Third, differentiating the both sides by using the chain rule. And the last step, multiply both sides with the function f of x. And let's see how this works to an example. Differentiate y equal to a raised to x with respect to x, where a is a positive constant. Let's see the solution. Here, y equal to the given function, that is a raised to x. Applying the log on both sides, we get log y is equal to x log a. Next step, we have to take the derivative using chain rule. So, 1 by y into dy by dx is equal to log a into derivative of x, which is 1. Now, what is dy by dx? Taking y to the other side, that is y into log a. And what is y? That is a raised to x. So, d by dx of a raised to x is equal to a raised to x into log a. Simple steps. Now, we have seen different methods to solve a function in which x and y are related to each other implicitly or explicitly. And do you know how to solve a function in which x and y are expressed in terms of third parameter? Let's find out. Now, it's time to wrap up the entire section.
Manorama Horizon. Learning made simple.